What's up everybody, how's it going? In this video I'm going to solve the next Leetcode challenge which here is Minstack. So I'll read out the question first. We have to push, pop and retrieve the top and minimum elements in constant time. Design a stack in such a way that supports all these operations. Okay. So the simplest way to do this without considering the space and time complexities is the brute force solution, and we'll do that in a second. So, just have a stack and push everything into the stack, and then pop. These are pretty basic operations. Return dot stack of -1, and here just return the minimum of the stack. Yes, so we'll see if it runs. As I have said, this is not a constant time operation when you try to remove the or when you try to retrieve the minimum element. So this is an order of n time complexity, though the answer will be correct. Yes, this is an accepted solution, but they mentioned that the minimum element has to be retrieved in constant amount of time. So to do this, we need to think about the solution. So we can simply maintain a minimum variable and try to whenever we push a new element into the stack, if the element is lesser than the minimum value, we can make the minimum variable as the current element x. But in the case when we have to pop the element and the element that we are going to pop is a minimum element, that means again we have to do an order of n time complexity operation to get back to the next minimum element, right? To reduce this order of n to order of 1, we can think of a small tweak in the ideology. That is, so we can do this while pushing the element into the stack. Whenever we are pushing a new element, if the element is lesser than the current minimum, when I mean what do I mean by current minimum? The minimum of all the elements are pushed up until now into the stack. So when we are pushing an element that is lesser than the minimum, so suppose we are pushing an x and we have the minimum variable mn. So if that x is lesser than the current minimum, then we just push first the minimum and then the x and make the minimum as x. So this will help. So we'll see by coding it up. Self.minimum is equal to, so at first before pushing everything into the stack we don't have any element minimum, so we just say infinity. So this helps when we are taking the minimum of x and the current minimum, right? So the minimum variable itself is the current minimum. So before directly pushing x, if x is less than or equal to self.minimum, so at this point we have to push the minimum into the stack along with x. So by this, when you are popping up the minimum element, we have the previous minimum already pushed into the stack, right? We are pushing these extra elements, making sure that every minimum element has the previous minimum under that in the stack. So we just push that into the stack. Push x, sorry, not x, yes, self.minimum. So and then that's it. This should and also self.minimum will be obviously x. And while popping the element, we just have to make sure that the if the popped element is equal to the minimum, that means if self.minimum is equal to self.stack.pop, That means we have to update the minimum to be the previous minimum, right? And also we don't want the previous minimum to be as a part of the stack. So what we just do is self.minimum is equal to self.stack.pop, and these things doesn't change. So here we just have to return the self.minimum, and we'll try running this now. Yeah, this worked. Yeah, done. So the basic ideology can be understood very clearly here. When instead of just pushing the every new element, we are pushing the previous minimum element also into the stack, or only when the current element is lesser than the current minimum. So this makes sure that we don't have to check over the entire stack over and over again. So that's it, guys. That's it for this video. If you have liked this, please share and subscribe. We'll keep uploading more content. Stay home, stay safe. Thank you for watching.